some cell stoic problems using Faraday's law from high school chemistry. If you are looking to try this worksheet before you take a look at this video, please go to my website. The link is in the description. Once you're in the website, just scroll to the chemistry section, and then anything highlighted in yellow is a worksheet. And if you go down to cell stoic, you'll see the cell stoic worksheet right there. If you do find this helpful, please make sure to subscribe and let me know if there's any other videos that you need help in. So before we get started, you do definitely need to know this formula, and the formula is moles of electrons equals your current times your time divided by Faraday's constant. Now in chemistry 30, you are given this number of Faraday's constant in your data booklet, but you do definitely want to pay attention to these units, in particular time, that it is in seconds. The other part here that you want to remember, anytime you're using cell stoic, you only need the half reaction of whatever is getting plated, or if your metal is losing mass, just a half reaction of that, which if you can't figure it out, you could probably find it on page 7 of your data booklet. And every now and then we'll use molar mass to figure out mass deposited or mass removed. So this first one, going right into a question, we have so let me just take that out here for a second. We have a current of 2.50 amps. It's passed through silver nitrate solution for 45 minutes. We want to calculate the moles of electrons transferred. So when we're looking at silver nitrate, right, it would only be silver that would be able to deposit a metal. The nitrate would not make a metal. So we just need the half reaction for silver, and that's what we are seeing right here. Now, if you're calculating moles of electrons, you are using that formula where it's amps, which is 2.50 times your time, and the time here's in minutes, and we do know our time needs to be in seconds. So we'll multiply this by, there are 60 seconds in 1 minute, so that we can see minutes canceling, and this is all over Faraday's constant. So 96485 coulombs per moles of electrons. So you go ahead and put this into your calculator, and you will find out that your answer, once you round it, is 0.0700 moles of electrons. Now, the second part is to find the mass. So I would go back to the number that's in my calculator before, instead of rounding too early. And that was a number like 0.0699, and this number keeps going. So that would be moles of electrons. Now you have to multiply it by your molar ratio, turning moles of electrons into moles of silver. So that's a 1-to-1 ratio. So it's not really going to do anything. It's just going to change your units. So here was moles of electrons, and then here moles of silver. And then I'm just running out of room, so I'm going to continue down here. Then I'm going to multiply this by my molar mass of silver. And this question's nice to us, like this worksheet is, and it's giving us the molar mass, so we don't need to look it up, but it's in our data booklet if we need it. So we'll see the moles of electron cancel. You'll see that moles of silver cancel, and what you're left with is grams of silver, and that will end up being 7.55 grams. So that's our first example. Our second example here is one to do with copper, and the same thing. If it doesn't tell us that it's copper that's being plated, you'd be able to figure it out because the metal part is what's going to be plated in electroplating or losing mass, depending what's happening within the cell. So same thing with this one. We're calculating the amount of moles of electrons transferred. So moles of electrons transferred, you need the formula, which is your amps times your time, but your time has to be in seconds. So we're going to multiply our hours by 3,600 seconds, which are in 1 hour. So hours can cancel, and all of this is divided by Faraday's constant. So 96485 coulombs per moles of electrons. We do all this work, plug it into your calculator, and you'll find out that that is 0.149 moles of electrons. Same like our other question, don't round too early, so keep that value in your calculator, your moles of electrons, and multiply by your mole ratio, because the second one is finding mass of copper. So we're here, we need to get to mass of copper. So we have a 2-to-1 ratio, so 1 mole of copper for 2 moles of electrons. And then we can multiply by our molar mass of copper, which again is given here, but if it wasn't, just grab that from the periodic table. So grams per mole, we see things canceling out nicely, and you will be left with your amount in grams of copper being deposited. So there's our first two examples. There are a few more going through the same thing. So if I take a look at this next one, we have amps, and we're plating nickel. So if you're plating nickel, we need that half reaction. We have our minutes, we'll need that to be in seconds, and we're going to calculate our moles. So moles of electrons will equal 4.75 amps times 32.0 minutes times 60 minutes in 60 seconds. Seconds in 1 minute. Minutes cancel. This is all divided by Faraday's constant, 96485 coulombs per moles of electrons. Again, remember that you don't need to memorize that number. It is in your data booklet. And once you plug this into your calculator, you should get 0.0945 moles of electrons. So throughout this worksheet, I've just been keeping 3 sig digs because that's what my question had. So I'm just, that's why I'm rounding my answers there. But then same thing, when you are doing your calculation, just make sure to keep that value that was in your calculator and don't round too early. So now we're looking for mass of nickel deposited. We are at moles of electrons. We'll need to use the mole ratio to turn it into moles of nickel. And then we can get the mass. Moles of, I meant to write electrons here. And then we get the mass, which again is given to us, but if it wasn't, get it from your data booklet. I know I'm getting really messy here, but I'm trying to fit it here. So we'll see things canceling nicely, and plug this all into your calculator, and you should get this nice value of 2.77 grams of nickel being deposited. So if you need a little bit more practice, here's a couple more. So we have zinc, in this case, zinc chloride. Again, the metal would be the one making the solid, so that's what we need for the half reaction. It's telling us that we have 1.85 amps. So again, calculating moles of electrons first, using this formula, 1.85 amps. Multiply it by your time. Time must be in minutes, so using the conversion between, oh my goodness, time must be in seconds. So using the conversion between hours and seconds, and then dividing that all by Faraday's constant. Plugging that into our calculator, keeping 3 significant digits, and we're getting 0.138 moles of electrons. Keeping that unrounded value in your calculator, we are going to convert that to moles of our solid zinc. So times 1 mole of zinc over 2 moles of electrons. And then lastly, multiplying by your molar mass of zinc. And we'll see things canceling nicely. And we end up with 4.51 grams of zinc getting deposited. This last one, and also just to talk about how you could also see this question. So this last one, we're doing the same thing as always. It's telling us electrolysis of molten aluminum oxide. That just means instead of being in the aqueous state, you're a pure liquid, but it would still be the metal that would be deposited. So we wouldn't worry about oxygen. We have that half reaction for aluminum. And doing the same thing, again, just being careful for that mole ratio. When you do that second part, we are getting moles of electrons. We're going to multiply by our time, change it to seconds. Divide it by all of that by Faraday's constant. It's 485 coulombs per moles of electrons. And then just for that first part, getting three significant digits, 0.19 moles of electrons. And then, like all the other ones, don't round too early. Keep that value in your calculator, and then turn your moles of electrons into moles of the metal using that mole ratio. So 1 mole of aluminum over 3 moles of electrons. And then using that molar mass to turn it into grams. And we do that all correctly, we should get 1.97 grams. Just to mention here, the other times you can see this question are, instead of starting with the formula, you could start, say, on this side and do all the work. Like, you'll have the amount in grams, like here, you would change it to moles, go to the mole ratio, get moles of electrons, and then use mole of electrons within this formula to find something like amps times or time. So just knowing that we can start on the other end of this question as well. As always, I hope you found this helpful. If you're looking for more, just please check out my website. It has all chemistry topics, and if you're in calculus, there's a link for that as well. If you did find this helpful, please subscribe, and thank you very much for watching.